Okay, this is the second video for our in-class differentiation practice that has to do with exponential functions along with trig derivatives as well and power functions. So I wanted to kind of do this with you to have you practice. And these are, the second video of what I started. And I will make sure that we're doing the evens because I've assigned you the odds and they have all the answers in the back of the book. So I have this function here. You've already seen I've kind of set it up. I see the top is a trig function. The bottom is a trig function. And what I want to do is find the derivative. I see it's a quotient. So I set up my f and g's. So my f is 1 minus secant x. My g is tan x. My f prime is the derivative of 1 is 0. The derivative of negative secant x is negative secant tan x. And then g is tan x, and the derivative of tan x is secant squared. So let's start doing the derivative to this. And this is kind of a fun one because you always are on the lookout for, I always say be on the lookout for any kind of identities. And I'm going to do f prime g. So I'm going to actually, when I multiply that, make that a negative secant x tan squared x, okay, minus fg prime. And I'm going to put that in the front, the g prime in front of the f. All over g squared. Okay, all over tangent squared x. Now I'm just kind of work out. I look at it, I have a term here and a term here. And I can see right here I have a secant x, and here I can take out a secant x. So now I have y prime. If I take a secant x out, I have a negative tan squared x minus secant x, because I'm going to divide out one of the secants x times 1 minus secant x. So all I did was divide out of this first term as the secant x, so there's a negative tan squared left, minus there's only one secant left as I divide that out, all over g squared. And then what I'm going to do here is do the distributive property and go through there. So I have y prime equals secant x, okay? And then I have a negative tan squared x minus secant x plus secant squared x all over tangent squared of x. Now, as I do this, I'm always on the lookout for identities. I see I have a negative tan squared x here, and I have a positive secant squared there. So I'm going to see, is there an identity that will help me simplify this? And there is. The identity is as follows. So here's my identity. And the identity is tangent squared x plus 1 is secant squared x. And I see I have a secant squared and a minus tan, so I'm going to move this over here. So I have secant squared x. So I'm going to move the tangent squared x over there, turns negative, and that equals 1. So these two in the yellow circle here add up to 1. Secant squared x minus tan squared x equals 1. So that simplifies this very nicely to say y prime is secant x times 1 minus secant x, because that's what those two came out to be, is a 1 all over tangent squared x. And that'll be the final way to simplify this, and it's in factored form. All right, so I have a couple more. So on this next page, there's a 20 at the top, and at the bottom I'm going to put 32. So I know you have one up here and it's already typed out. I don't know what happened, so I just kind of rewrote it. So I'm going to do number 20 at the top and at the bottom 32. So we're going to use half a page for each. It's right in your packet. So it says find the equation of the tangent line at the given point. So here's my graph. I know I've got to do this. Y minus y1 equals mx minus x1. They already gave me the point, so I know definitely I'm going to throw in here a 1 in for y and a 0 in for x. Okay? So I have to do the derivative so that I can find the slope. Right? So let's do it. I see this is a product. So I'm going to set up my work. F is e to the x. F prime is e to the x. G is cosine of x. G prime is negative sine of x. So if you have your derivative card out and you get going on this, it gets a little bit easier. So I know that y prime is f prime g, e to the x, cosine of x, okay, minus f g prime, and it actually turns f prime g, and it's actually a plus, excuse me, because this is product rule, please forgive me. So it's plus, and it turns negative because I have a negative sine x, e to the x times sine x. And Mrs. Pond always likes it in factored form, so let's do that. So I got y prime, and I have a term here and a term here. So if I factor out e to the x, I have cosine of x minus sine of x. Okay, now I'm good because I just have to find my slope here, and I know it's at the point 0, 1, so the x is 0, so I'm going to actually do y prime of 0 and plug that in. And when I do that, I have e to the 0 times cosine of 0 minus sine of 0. Now, I know you have calculators, but if you memorized everything I told you before, e to the 0 is 1, so that's cool. Cosine of 0 is 1, okay? So I have 1 times 1 minus, and the sine of 0 is 0. So it comes out to be a slope of 1. So my line comes out to be right here, y minus 1 equals the slope of 1, x minus 0. So y equals x plus 1. So I distributed that, moved the 1 over. So there is my tangent line. Now I actually graphed this so we could check it. So let's look at our graph right here. And I graphed e to the x cosine x. And as you can see, the slope is at 1 at 0. And then I did the tangent line, and so line is y equals x plus 1. So you can graph it and check it. I did go all the way up to 50 here, and I know it's turning up here somewhere, but I think you have to go all the way up to like 500 or more, and you couldn't even see the tangent line. So that's why I kind of did it like this. Okay. All right, let's look at the next one we want to do. So at the bottom of this same page, I know it's blank on yours. I want you to write number 32 because this is what it's one of the practice problems in this same section, and it will help you. And this is what it is. For what values of x does the graph of f of x have a horizontal tangent? And the first thing I do is, okay, horizontal tangent lines look like this, okay? And I know it's y equals something. Y equals a number, okay? So if I want to know for what value of x does it have this horizontal tangent line, if I know that this slope here is 0, I can just do the first derivative, which is my slopes, put it equal to 0 and figure out what the x's would be. Okay, so I notice this is a product rule. So I have f is e to the x, f prime is e to the x, g is cosine of x, g prime is negative sine of x. Okay, so now, sorry about that, guys, it's my phone. So I've got all this stuff going on here, and now what I'm going to do is the derivative. So I'm going to do f prime of x is going to be f prime g plus f g prime, and it turns minus because of that. Okay, so here we go. And I've got it all done. And what I'm going to do is do this in factored form before I put it equal to 0. So I got f prime of x. And here's a term here, and here's a term here. So I'm going to factor out the e to the x. When I do, I have cosine of x minus sine of x. Now I'm going to put this equal to 0 so I can figure out what the x's are that I can make a horizontal tangent line. So I'm going to make my big T here. So I have e to the x can never equal 0, so thanks for your help. And then I have cosine of x minus sine of x equals 0. And if I move the sine x over, this is what I get. I get cosine of x equals sine of x. And you're like, what am I going to do with that? But if you remember your table, isn't when x is pi over 4 or 45 degrees that your cosine and sine have a value of radical 2 over 2? So I know that if I plug a pi over 4 here to pi over 4 here, they're going to match and that they're equal to each other. And the only two quadrants, now if you think about this, so I'm going to draw this picture, okay? If sine and cosine are the same and it's pi over 4, they're only the same signs in quadrant 1 where sine and cosine are positive, so in quadrant 1. And in quadrant 3, sine and cosine are both negative. In these two quadrants, they're not. So here it's negative positive, and here it's positive negative. So you could get the same values, but the signs will be different. So basically, in quadrant 1, I'm going to have an answer, which is pi over 4, but there's already an answer here in this quadrant. So what I've showed you guys before is if you have something with a denominator of 4, this is pi, so this is 4 pi over 4. And if I use my reference angle, so one of my answers is going to be pi over 4 because it's in quadrant 1. Here, if I add pi over 4 to that, it's 5 pi over 4. So at pi over 4 and at 5 pi over 4, so there's two answers to this, that I'm going to have a horizontal tangent line. So I'm actually going to bring up the graph because I graphed this already, okay? And it's right here. So I graphed this, and I actually counted by pi over 4. So here's pi over 4, 2 pi over 4, 3 pi over 4, all the way over. And you'll see here at pi over 4, there's a horizontal tangent line, and here this is 5 pi over 4. So if you were to count 1, 2, 3, 4, 5 pi over 4 is the other horizontal tangent line, okay? And that is the end of this video. So thank you for that, and sorry about the interrupted of the phone call. Have a great day.